The Electric Orrery. Half Moon Junction. Change here for Venus, Mercury, the Earth, Mars, Jupiter, Saturn, Uranus, Neptune. So I called in the style of a Clapham railway porter, as I entered the observatory of Professor Gazin on the following night. "What is the matter?" said he with a smile. "Are you imitating the officials of the Universal Navigation Company in the distant future?" "Not so distant as you may imagine," I responded significantly, and then I told him all that I had seen and heard of the new flying machine. The professor listened with serious attention, but manifested neither astonishment nor skepticism. "What do you think about it?" I asked. "What should I do in the case?" "Well, I hardly know," he replied doubtfully. "It is rather out of my line, and after my experience with Mars the other night, I am not inclined to dogmatize. At all events, I should like to see and try the machine before giving an opinion." "I will arrange for that with the inventor. Possibly I can find out something about him from my American friends if he is genuine." "What's his name again?" "Carmichael, Naismith Carmichael." "Naismith Carmichael," repeated Gazin, musingly. "It seems to me I've heard the name somewhere. Yes, now I recollect. When I was a student at Cambridge, I remember reading a textbook on physics by Professor Naismith Carmichael, an American, and a capital book. It was beautifully simple, clear, and profound like nature herself. Professors, as a rule, and especially professors of science, are not the best writers in the world. Pity they can't teach the economy of energy without wasting that of their readers." Carmichael's book was not a dead system of mathematics and figures, but rather a living tale, with illustrations drawn from every part of the world. I got far more help from it than the prescribed treatises, and the best of that was a liking for the subject. I believe I should have been plucked without it. The very man, no doubt. He was remarkably sane when he wrote that book, whatever he is now. As to his character, that is another question. Given a work of science, to find the character of the author. Problem. I shall proceed cautiously in the affair. Before I commit myself, I must be satisfied by inspection and trial that there is neither trickery nor self-delusion on his part. We can make some trial trips, and gain experience before we attempt to leave the world. If you take my advice, you will keep to the earth altogether. Surely, if we can ascend into the higher regions of the atmosphere, we can traverse empty space. You would have me stop within sight of the goal. The end of travel is to reach the other planets. Why not say the fixed stars when you are about it? That's impossible. On the contrary, with a vessel large enough to contain the necessaries of life, a select party of ladies and gentlemen might start for the Milky Way, and if all went right, their descendants would arrive there in the course of a few million years. Rather a long journey, I'm afraid. What would you have? 1,000,000 years, quotha? Nay, not so much. It depends on the speed and the direction taken. If they were able to cover, say, the distance from Liverpool to New York in 1/10 of a second, they would get to Alpha in the constellation Centaur, perhaps the nearest of the fixed stars, in 20 or 30 years, a mere bagatelle. But why should we stop there? Went on Gazin. Why should we not build large vessels for the navigation of the ether artificial planets, in fact, and go cruising about in space, from universe to universe, on a celestial Cook's excursion? We are doing that now, I believe. Yes, but in tow of the sun. Not at our own sweet will, like gypsies in a caravan. Independent, free of rent and taxes, these hollow planetoids would serve for schools, hotels, dwelling houses. and lunatic asylums. They would relieve the surplus population of the globe, continued Gazin, warming to his theme. It is an idea of the first political importance, especially to British statesmen. The empire is only in its infancy. With a fleet of ethereal gunboats we might colonize the solar system and annex the stars. What a stroke of business! Another illusion gone, I observe. Think of Manchester cotton in the Pleiades. Of Scotch whiskey in Orion. However, I am afraid your policy would lead to international complications. The French would set up a claim for ancient lights. The Germans would discover a nebulous hinterland under their protection. The Americans would protest in the name of the Munro Doctrine. It is necessary to be modest. Let us return to our muttons. Everybody will be able to pick a world that suits him, pursued Gazin, still on the trail of his thought. If he grows tired of one, he can look round for a better. Criminals will be weeded out and sent to Coventry, transplanted into a worse. When a planet is dying of old age, the inhabitants will flit to another. Seriously, if Carmichael's machine turns out all right, will you join me in a trip? Thanks, no. I believe I shall wait and see how you get on first. And where would you advise me to go, Mars or Venus? The professor smiled, but I was quite in earnest. Well, he replied, Mars is evidently inhabited, but so is Venus, probably, and of the two I think you will find her the more hospitable and the nearest. When do you propose to start? Perhaps within 6 months. We must consider their relative distances from the Earth. By the way, I don't think you have seen my new electrical orrery. An electrical orrery, I exclaimed. Surely that is something new. So far as I am aware, but you never know in these days. There is nothing new under the sun, or even above it. So saying, he opened a small door in the side of the observatory, and, ushering me into a very dark apartment, closed it behind us. Follow me, there is no danger, said he, taking me by the arm, and guiding me for several paces into the darkness. At length we halted, and I looked all around me, but was unable to perceive a single object. Where are we? I inquired. In the realms of chaos and old night? You are now in the center of the universe, replied Gazin, or, to speak more correctly, at a point in space overlooking the solar system. Well, I can't see it, said I. Have you got such a thing as a match about you? Let there be light, responded Gazin in a reverent manner, and instantly a soft, weird radiance was over all. The contrast of that sudden illumination with the preceding darkness was electrical in more senses than one, and I could not repress a cry of genuine admiration. A kind of twilight still reigned, and after the first moment of surprise, I perceived that we were standing on a light metal gangway in the middle of a great hollow cell of a luminous black or dark blue color, relieved by innumerable bright points, and resembling the night sky in miniature. I need hardly say that is a model of the celestial sphere, whispered Gazin, indicating the starry vault. It is a wonderful imitation, I responded, my awestruck eyes wandering over the mysterious tracts of the Milky Way and the familiar constellations of the mimic heavens. May I ask how it is done, how you produce that impression of infinite distance? By means of translucent shells illuminated from behind. The stars, of course, are electric lamps, and some of them, as you see, have a tinge of red or blue. Most of the light, however, came from a brilliant globe of a bluish luster, which appeared to occupy the center of the crystal sphere, and was surrounded by a number of smaller and fainter orbs that shone by its reflected rays. This, again, is a model of the solar system, said Gazin. The central luminary is, of course, the Sun, and the others are the planets with their satellites. They seem to float in air. That is because their supports are invisible, or nearly so. Both their lights and periodic motions are produced by the electric current. Surely they are not moving now? Oh, yes, and with velocities proportionate to those of the real bodies, but you know that whilst the actual movements of the Sun and planets are so rapid, the dimensions of the system are so vast that if you could survey the whole from a standpoint in space, as we are supposed to do, it would appear at rest. Let us look at them a little closer. I followed Gazin along the gangway which encircled the orrery, and allowed us to survey each of the planets closer at hand. This kind of place would make a good theater for a class in astronomy, said I, or for the meetings of the Interplanetary Congress of Astronomers, in the year 2000. You can turn on the stars and planets when you please. I wish you would give me a lecture on the subject now. My knowledge is a little the worse for wear, and a man ought to know something of the worlds around him, especially if he intends to visit them. I should only bore you with an old story. Not at all. You cannot be too simple and elementary. Regard me as a small boy in the stage of Twinkle, twinkle, little star. How I wonder what you are. Very well, my little man, have you any idea how many stars you can see on a clear night? Billions. No, Tommy. You are wrong, my dear boy. Go to the foot of your class. With the naked eye we can only distinguish 3,000 or 4,000, but with the telescope we are able to count at least 50 millions. They are thickest in the Milky Way, which, as you can see, runs all round the heavens, over your head, and under your feet, like an irregular tract of hazy light, a girdle of stars in short. Of course we cannot tell how many more there are beyond the range of vision, or what other galaxies may be scattered in the depths of space. The stars are suns, larger or smaller than our own, and of various colors: white, blue, yellow, green, and red. Some are single, but others are held together in pairs or groups by the force of gravitation. From their immense distance they appear fixed to us, but in reality they are flying in all directions at enormous velocities. Alpha, of the constellation Cygnus, for example, is coming towards us at a speed of 500 million leagues per annum, and some move a great deal faster. Most of them probably have planets circling round them in different stages of growth, but these are invisible to us. Here and there amongst them we find luminous patches or nebulae, which prove to be either clusters of stars or stupendous clouds of glowing gases. Our Sun is a solitary blue star on the verge of the Milky Way, 20 billion miles from Alpha Centauri, his next-door neighbor. He is traveling in a straight line towards the constellation Hercules at the rate of 20,000 miles an hour, much quicker than a rifle bullet, and, nevertheless, he will take more than 1,000,000 years to cover the distance. 8 large or major planets, with their satellites, and a flock of minor planets or planetoids, are revolving round him as their common center and luminary at various distances, but all in the same direction. The orbits, or paths, about the Sun are ovals or ellipses, almost circular, of which the Sun occupies one focus, and they are so nearly in one plane, or at one level, that if seen from the Sun, they would appear to wander along a narrow belt of the heavens, called the zodiac, which extends a few degrees on each side of the elliptic or apparent course of the Sun against the stars. The planets are all globes, more or less flat at the poles, like an orange, and each is turning and swaying on its axis, thus exposing every part to the light and warmth of the Sun. They are divided by the planetoids into an inner and an outer band. The inner 4 are Mercury, Venus, the Earth, and Mars. The outer 4 are Jupiter, Saturn, Uranus, and Neptune. Moreover, a number of comets and swarms of meteoric stones or meteorites are circulating round the Sun in eccentric paths, which cross those of the planets. Such is the solar system, a lonely archipelago in the ethereal ocean, a little family of worlds. Not without its jars, I'm afraid. The sun is chief of the clan, continued Gazin, and keeps it together by the mysterious tie of gravitation. While flying through space, he turns round his own axis like a rifled bullet in 25 or 26 days. His diameter is 860,000 miles, and although he is not much denser than seawater, his mass is over 700 times greater than the combined mass of all his retinue. Gravity on his surface being 28 times stronger than on the Earth, a piece of timber would be as heavy as gold there, and a stone let fall would drop 460 feet the first second instead of 16 feet as here. He is built of the same kind of matter as the Earth and other planets, but is hotter than the hottest electric arc or reverberatory furnace. Apparently his glowing bulk is made up of several concentric shells like an onion. First there is a kernel or liquid nucleus, probably as dense as pitch. Above it is the photosphere, the part we usually see, a jacket of incandescent clouds, or vapors, which in the telescope is seen to resemble willow leaves, or rice grains in a plate of soup, and in the spectroscope to reveal the rays of iron, manganese, or other heavy elements. What we call faculae, or little torches, are brighter streaks, not unlike some kinds of coral. The sunspots are immense gaps or holes in the photosphere, some of them 150,000 miles in diameter, which afford us a peep at the glowing interior. There are different theories as to their nature, hence they provide rival astronomers with an excellent opportunity of spotting each other's reputations. For instance, I look upon them as eruptions, and Professor Sylvanus Pettifer Possel, my pet aversion, regards them as cyclonic storms. Consequently we never lose an opportunity of erupting and storming at each other. Above the photosphere comes a stratum of cooler vapors and gases, namely, hydrogen and helium, a very light element recently found on the Earth, along with argon, in the rare mineral clevite. Tremendous jets of blazing hydrogen are seen to burst through the clouds of the photosphere, and play about in this higher region like the flames of a coal fire. These are the famous red flames or prominences, which are seen during a total eclipse as a ragged fringe of rosy fire about the black disk of the moon. Some of them rush through the chromosphere to a height of 80,000 miles in 15 minutes. Higher still is the corona, an aureole of silvery beams visible in a total eclipse, and resembling the star of a decoration. The streamers have been traced for hundreds of thousands of miles beyond the solar disk. It appears to consist of meteoric stones, illuminated by the sunlight, as well as of incandescent vapors of coronium, a very light element unknown on the Earth, and probably, too, of electrical discharges. The zodiacal light, that silvery glow often seen in the west after sunset, or in the east before sunrise, may be a prolongation of it. I dare say these meteorites are swarming about the sun like midges about a lamp, said I. And just as eager to get burnt up, replied Gazin, with a smile. Let us pass now to the planets. The little one next the sun is Mercury, who can be seen as a rosy white star soon after sunset or before sunrise. He is about 36 million miles, more or less, from the sun, travels round his orbit in 88 days, the length of his year, and spins about his axis in 24 hours, making a day and night. His diameter is 3,000 miles, and his mass is nearly 7 times that of an equal volume of water. The attraction of gravity on his surface is barely half that on the Earth, and a man would feel very light there. Mercury seems to have a dense atmosphere, and probably high mountains, if not active volcanoes. The sunshine is from 4 to 9 times stronger there than on the Earth, and as summer and winter follow each other in 6 weeks, he is doubtless rather warm. Venus, the shepherd's star, and the brightest object in the heavens after the moon, can sometimes be seen by day, and casts a distinct shadow at night. She is about 67 million miles from the sun, revolves round him in 225 days, and rotates on her axis in 23 to 24 hours, or as Schiaparelli believes, in 224 days. Her diameter is 7,600 miles, and her mass nearly 5 times that of an equal volume of water. Gravity is rather less there than it is here. Like Mercury, she appears to have a cloudy atmosphere, and very high mountains. On the whole she resembles the Earth, but is, perhaps, a younger as well as a warmer planet. The green ball, next to Venus, is, I need hardly say, our own dear little world. Terra, or the Earth, is 93 million miles from the Sun, goes round him in 365 days, and turns on her axis in 24 hours less 4 minutes. Her diameter is 7,918 miles, and her density is 5.66 times that of water. She is attended by a single satellite, the Moon, which revolves round her in 27.3 days, at a distance of 238,000 miles. The Moon rotates on her axis in about the same time, and hence we can only see one side of her. She is 2,160 miles in diameter, but her mass is only 1/80th that of the Earth. A pound weight on the Moon would scale 6 pounds on the Earth. Having little or no atmosphere or water, she is apparently a dead world. The red planet beyond the Earth is Mars, who appears in the sky as a ruddy gold or coppery star. He is 141 million miles from the Sun, travels his orbit in 687 days, and wheels round his axis in 24 hours 37 minutes. His diameter is 4,200 miles, and his mass about 1/9 that of the Earth. A body weighing 2 pounds on the Earth would only make half a pound on Mars. As you know, his atmosphere is clear and thin, his surface flat, and subject to floods from the melting of the polar snows. Mars is evidently a colder and more aged planet than the Earth. He is accompanied by 2 little moons, Phobos, Fear, which is from 10 to 40 miles in diameter, and revolves round him in 7 hours 39 minutes, at a distance of 6,000 miles, a fact unparalleled in astronomy, and Deimos, Route, who completes a revolution in 30 hours 18 minutes, at a distance of 14,500 miles. About 400 planetoids have been discovered up to now, but we are always catching more of them. Medusa, the nearest, is 198 million miles, and Thule, the farthest, is 396 million miles from the Sun. Vesta, the brightest and probably the largest, a pale yellow, or, as some say, bluish-white orb, visible with the naked eye, is from 200 to 400 miles in diameter. It is impossible to say which is the smallest. Probably the mass of the whole is not greater than 1/4 that of the Earth. Jupiter, surnamed the giant planet, who almost rivals Venus in her splendor, is 480 million miles from the Sun, travels round his orbit in 12 years less 50 days, and is believed to whirl round his axis in 10 hours. His diameter is 85,000 miles, and his bulk is not only 1,200 times that of the Earth, but exceeds that of all the other planets put together. Nevertheless, his mass is only 200 to 300 times that of the Earth, for his density is not much greater than that of water. What we see is evidently his vaporous atmosphere, which is marked by colored spots and bands or belts, probably caused by storms and currents, especially in the equatorial regions. Jupiter is thought to be self-luminous, at least in parts, and is, perchance, a cooling star, not yet entirely crusted over. 4 or 5 numbered satellites, about the size of our Moon and upwards, are circulating round him in orbits from 2,000 to 1 million miles distant in periods ranging from 11 hours to 16 days 18 hours. Saturn, the ringed planet, who appears as a dull red star of the first magnitude, is the most interesting of all the planets. He is 884 million miles from the Sun, his period of revolution is 29.5 years, and he turns on his axis in 10 hours 14 minutes. His diameter is 75,000 miles, but his mass is only 94 times that of the Earth, for he is lighter than pinewood. His atmosphere is marked with spots and belts, and on the whole his condition is like that of Jupiter. 2 flat rings or hoops, divided by a dark space, encircle his ball in the plane of his equator. The inner ring is over 18,000 miles from the ball, and nearly 17,000 miles broad. The gap between is 1,750 miles wide, and the outer ring is over 10,000 miles broad. The rings are banded, bright or dark, and vary in thickness from 40 to 250 miles. They consist of innumerable small satellites and meteoric stones, traveling round the ball in rather more than 10 hours, and are brightest in their densest parts. Of course they form a magnificent object in the night sky of the planet, and it may be that our own zodiacal light is the last vestige of a similar ring, and not an extension of the solar corona. Saturn has 8 moons outside his rings, the nearest, Mimas, being 115,000, and the farthest, Japetus, 220,400 miles from his ball. With the exception of Japetus, they revolve round him in the plane of his rings, and when these are seen edgewise, appear to run along it like beads on a string. Uranus, the next planet visible, is a pale star of the 6th magnitude, 1,770 million miles from the Sun, and completes his round in 84 years. His axis, differing from those of the foregoing planets, lies almost in the plane of his orbit, but we cannot speak as to his axial rotation. He is 31,000 miles in diameter, and somewhat heavier, bulk for bulk, than water. For satellites revolve round him, the nearest, Ariel, being 103,500, and the farthest, Oberon, 347,500 miles distant. Unlike the orbits of the foregoing satellites, which are nearly in the same plane as the orbits of their primaries, those of the satellites of Uranus are almost perpendicular to his own. They are traveled in periods of 2.5 to 13.5 days. Neptune, invisible to the naked eye, but seen as a pale blue star in the telescope, is 2,780 million miles from the Sun, and makes a revolution in 165 years. His diameter is about 35,000 miles, and his density rather less than that of water. Neptune has one satellite, at a distance of 202,000 miles, which, like those of Uranus, revolves about its primary in an orbit at a considerable angle to his own in 5 days 21 hours. Both Neptune and Uranus are probably dying suns. Comets of unknown number travel in long elliptical or parabolic orbits round the Sun at great velocities. They seem to consist partly of glowing vapors, especially hydrogen, and partly of meteoric stones. Shooting stars, that is to say, stones which fall to the earth, are known to swarm in their wake, and are believed to be as plentiful in space as fishes in the sea. The trash or leavings of creation, said I reflectively. And the raw material, for nothing is lost, rejoined Gazin. Now, in spite of all its diversity, there is a remarkable symmetry in the solar system. The planets are all moving round the Sun in one direction along circular paths. As a rule, each is nearly as far again from the Sun as the next within it. Thus, if we take Mercury as 3/4 inch from the Sun, Venus is about 1¼ inches, the Earth 2¼ Mars 2, the planetoids 5¼ Jupiter 9¾ Saturn 14, Uranus 36, and Neptune 60 inches. On the same scale, by the way, Encke's comet at Aphelion, its farthest distance from the Sun, would be about 12 feet, Donati's almost a mile, and Alpha Centauri, a near star in the Milky Way, some 10 miles. The stately march of the planets in their orbits becomes slower the farther they are from the Sun. The velocity of Mercury in its orbit is 30, that of Jupiter is 8, and that of Neptune is only 3 miles a second. On the other hand, the inner planets, as a rule, take some 24 hours, and the outer only 10 hours to spin round their axis. The inner planets are small in comparison with the outer. If we represent the Sun by a gourd, 20 inches in diameter, Mercury will seem a bilberry, 6-inch, Venus, a white currant, the Earth a black currant, 1/4 inch, Mars a red currant, 1/8 inch, the planetoids as fine seed, Jupiter an orange or peach, 2 inches, Saturn a nectarine or greengage, 1 inch, Uranus a red cherry, 3/4 inch, and Neptune a white cherry, barely 1 inch in diameter. By putting the Sun and planets in a row, and drawing a contour of the whole, we obtain the figure of a dirk, a bodkin, or an Indian club, in which the Sun stands for the knob, disproportionately big, the inner planets for the handle, and the outer for the blade or body. Again, the average density of the inner planets exceeds that of the outer by nearly 5 to 1, but the mass of any planet is greater than the combined masses of all which are smaller than it. The inner planets derive all their light and heat from the Sun, and have few or no satellites, whereas the outer, to all appearance, are secondary suns, and have their own retinue of worlds. On the similitude of a clan or house, we may regard the inner planets as the immediate retainers of the chief, and the outer as the chieftains of their own septs or families. How do you account for the symmetrical arrangement? I inquired. The origin of the solar system is, a mystery, replied the astronomer. According to the nebular hypothesis, we may imagine that two or more dark suns, perhaps encircled with planets, have come into collision. Burst into atoms by the stupendous shock, they would fill the surrounding region with a vast nebula of incandescent gases in a state of violent agitation. Its luminous fringes would fly immeasurably beyond the present orbit of Neptune, and then rush inwards to the center, only to be driven outwards again. Surging out and in, the fluid mass would expand and contract alternately, until in course of ages the fiery tides would cease to ebb and flow. If the impact had been somewhat indirect, it would rotate slowly on its axis, and under the influence of gravity and centrifugal force acquire a globular shape which would gradually flatten to a lenticular disk. As it cooled and shrank in volume, it would whirl the faster round its axis, and grow the denser towards its heart. By and by, as the centrifugal force overcame gravity, the nebula would part, and the lighter outskirts would be shed one after another in concentric rings to mold the planets. The inner rings, being relatively small and heavy, would probably condense much sooner than the large, light, outer rings. The planetoids are apparently the rubbish of a ring which has failed to condense into one body, perhaps through its uniformity or thinness. The separation of so big a mass as Jupiter might well attenuate the border. If the planetoids were born of a single small ring, might not several planets be condensed from a large one? I see nothing to hinder it. A large ring might split into smaller rings, or condense in several centers. Because it seems to me that might explain the distinction between the inner and the outer planets. Perhaps the outer were first thrown off in one immense ring, and then the inner in a smaller ring. Before separation, the nebula viewed edgewise might resemble your Indian club. A dumbbell nebula, like those we find in the heavens, observed Gazin. Be that as it may, the rings would collect into balls, and some of these, especially the outer, would cast off rings which would condense into moons, always excepting the rings of Saturn, which, like the planetoids, are evidently a failure. The solar system would then appear as a group of suns, a cluster of stars, in short, a constellation. Each would be what we call a nebulous star, not unlike the Sun at present, that is to say, it would be surrounded by a glowing atmosphere of vapors, and perhaps meteoric matter. Under the action of gravity, centrifugal force, and tidal retardation, their orbits would become more circular, they would gradually move further apart, rotate more slowly on their axes, and assume the shapes they have now. In cooling down, new chemical compounds, and probably elements would be formed, since the so-called elements are perhaps mere combinations of a primordial substance which have been produced at various temperatures. The heavier elements, such as platinum, gold, and iron, would sink towards the core, and the lighter, such as carbon, silicon, oxygen, nitrogen, and hydrogen, would rise towards the surface. A crust would form, and portions of it breaking in or bursting out together with eruptions and floods of molten lava, would disturb the poise of the planet, and give rise to inequalities of surface, to continents, and mountains. When the crust was sufficiently stable, sound, and cool, the mists and clouds would condense into rivers, lakes, or seas, and the atmosphere would become clear. In due course life would make its appearance. Can you account for that mystery? No. Science is bound in honor, no doubt, to explain all it can without calling in a special act of creation, but the origin of life and intelligence seems to go beyond it, so far. Spontaneous generation from dead matter is ruled out of court at present. We believe that life only proceeds from life. As for the hypothesis that meteoric stones, the moss-grown fragments of another world, may have brought life to the earth, I hardly know what to think of it. Has life ever been found on a meteoric stone? Not that I know. Carbon, at all events in the state of graphite and diamond, has been got from them. They are generally a kind of slag, containing nodules or crystals of iron, nickel, and other metals, and look to me as if they had solidified from a liquid or vapor. Are they ruins of an earlier cosmos, the crumbs of an exploded world, matter ejected from the sun, the snow of a nebulous ring, frozen spray from the fiery surge of a nebula? We cannot tell, but, according to the meteoric as distinguished from the nebular hypothesis of the solar system, the sun, planets, and comets, as well as the stars and nebula were all generated by the clash of meteorites, and not as I have supposed, of dead globes. Which hypothesis do you believe? There may be some truth in both, replied Gazin. The two processes might even go on together. What if meteorites are simply frozen nebula? It is certain that the Earth is still growing a little from the fall of meteoric stones, and that part of the sun's heat comes from meteoric fuel. Most of it, however, arises from the shrinkage of his bulk. 5 or 10 million years ago the sun was double the size he is now. 20 or 30 million years ago he was rather a nebula than a sun. In 5 or 10 million more he will probably be as Jupiter is now, a smoking cinder. And the Earth, how long is it since she was crusted over? Anything from 10 to several hundred million years. In that time the stratified rocks have been deposited under water, the land and sea have taken their present configurations, the atmosphere has been purified, plants and animals have spread all over the surface. Man has probably been from 20 to 100,000 years or more on the Earth, but his civilization is a thing of yesterday. How long will the Earth continue fit for life? Perhaps 5 or 10 million years. The entire solar system is gradually losing its internal heat, and must inevitably die of sheer inanition. The time is coming when the sun will drift through space, a black star in the midst of dead worlds. Perhaps the system will fall together, perhaps it will run against a star. In either case there would probably be a new heaven and a new earth. Born like a phoenix from the ashes of the old, said I, feeling the justice of the well-worn simile. I dare say the process goes on to all eternity. Like enough. The sublime idea, with its prospect of the infinite, held us for a time in silence. At length my thoughts reverted to the original question which had been forgotten. Now, whether should I go to Mars or Venus? I inquired, fixing my eyes on these planets and trying to estimate their relative distances from the Earth. Gazin made a mental computation, and replied with decision. Venus. All right, I responded. Venus let it be.